Okay, class, we're at the end of the chapter 5 and we're going to do fit a line to data. With this, I'm just going to use the notes here because it has a lot of graphing and it's easier to use what they have. So I'm going to go for it step by step. So you've heard of scatter plots. So that's where you just plot points on a graph. And a scatter plot is used to determine whether there is a relationship between paired data. So they want to see if there's a relationship between the x and y's. So the first one, you can see that these scatter points are just plotted here. But if you look at the points, you can draw a line straight through in the middle. So if the y tends to increase as the x increases, so the y and x are increasing together, the paired data are said to have a positive correlation, and you can see it looks like a positive line going up. So it's very easy to spot. They don't have to be exactly in a line, but they're round about a line here. So you could draw a line right through the center and you can see that it's a positive correlation. So likewise here, you can see that the lines are scattered here, and if I draw a line right in the center of the data, you can see if the y tends to decrease, so the y is going down as the x increases, the paired data are said to have a negative correlation. You can look at it and you can tell, all right? It's very easy to tell. So you can see it's like a negative slope and this is a positive slope. So the last scatter plot, if x and y have no apparent relationship, you can see it's all over the place. None of them are bunched together, so there's no line that you could draw through that. They have relatively no correlation, so there's no connection between the two data points. All right, so we're going to look here and describe the correlation of data. So let me just bring this down a little bit so we can have a really clear view. Describe the correlation of data. So we're going to look at the first one. In this scatter plot, the first one is hours of studying and the test scores. So that's good. This should affect you. So this is a good one to look at. So they're looking here as the hours that you study. What's the correlation to the grade? So here, 2 hours of studying looks like just under a 60, 3 hours, maybe a 60, anywhere from 59 to about a 66 looks about. After 4 hours of studying, a 70, and 5 hours you can go from 70 to maybe a 76. So, and then 6 hours looks like you're getting an 80, and then 7 and 8. So you can see that if this data, if you went right in the middle, you can get a positive line going up. So you should see that according to this, the x and y's are increasing. So it shows that as the hours of study increase, the test scores tend to increase, and that makes sense. So that's a positive correlation, a positive relationship between the two. So here we've got test scores the same as here, but now they've changed it. Instead of hours of studying, now you're watching television. So now we're going to see the, remember this is the x's and this is the y's, okay? So you don't watch TV, or you just watch an hour of TV, your score or your test results around a 90, 2 hours, so you can see the y's are falling, going 90, 80, 70, that's what it meant for a negative, but the x's are increasing. So 2 hours of watching TV, 4 hours of watching TV, 6 hours of watching TV, 8 hours of watching TV, and this shouldn't be a surprise, because if you're watching TV and you're not spending any time studying, then you don't have the examples, you're not reviewing the material, so of course your score's going to go down. So by the time you've watched a whole day of television, you haven't done any studying, your scores are heading towards a 60, and some will be even lower. So this is definitely a negative correlation. you can clearly see between the two. Good examples that affect you guys. So remember this when you're studying. Okay, so example 2, we're going to use what is here. All right, so the table shows the length. We're making a scatter plot, and the table shows the length in centimeters and swimming speeds in centimeters per second of 6 fish. So you've got the pike, black bass, gurnard, whatever kind of fish that is, Norway haddock. So 1, 2, 3, 4, 5. It looks like 5 fish actually. Yeah. And you've got the lengths and the speeds. So you can see the lengths and speeds. So it says make a scatter plot of the data. So remember, you always have to put a title. So fish swimming speeds. That's a great title. It doesn't have to be anything fancy. So your Y's are going to be the speed, right? So you always look. The lowest is 47 and the highest goes up to 148. So they did it 0, 25, 50. They did it by 25s. So it fit nicely on the graph. And that's how you make it fit on any graph. You change the increments if you have to. So the Y's are going by 25s. So 150 is bigger than the 148. So you want it to be at least 150 or a little bit higher, so it will fit all the points on the data. Then this is obviously going to be the length of the fish. So the length. So you look, okay, well, smallest one is what, 19.2, and the largest one is 37.8. So you don't need to make these by 25s. They've decided to make them by increments of 5, 5, 10, 15, 20, 25, all the way up to 40. Okay, because the closest we get is 37.8, as long as you can include that. So length, and they wrote in centimeters, speed, centimeters per second. All right, so then we plot the data. So you plot the first one and you look to see if there's a relationship. So the length at 20, it's going close to 50. And you can see as the length increases of the fish, what happens? That the speed increases. So as y increases, x increases too. So we would say that this definitely shows a positive correlation, which means the longer fish tend to swim faster. So that's what they're looking for by correlation. They're looking for a relationship. So you always want to put your title, describe what y is and x, and do the increments. So you don't have to do everyone, but see how did 10, 20, 30, 40, and this is your x, this is your y. So you always have to do that. You can't just graph something, have no labels, because nobody has any clue what that means. So this is a very good graph showing everything. So that's what they asked you to do. All right. So down here, let's go through the instructions to make a scatter plot, because you're going to have to do a few. Using a line of fit to model data. So you're going to model the data now. We're going to take it one step further. You're going to draw a line through the center. So it says make a scatter plot of the data. So you're able to make your graph just like you saw and plot your points. Decide whether the data can be modeled by a line. So if it's all over the place and shows no correlation, you can't model it by a line. If it's x and y and increasing, then it's positive correlation. If y is decreasing, going down, but x is increasing, then you know it's negative. Then draw a line that appears to fit the data closely. So you want to go in the center. There should be approximately as many points above the line as below it. So you want to try and keep it, if there's 3 above it, 3 below it. So these are just advice on how you do it. Then you write an equation using 2 points on the line. So you have to pick 2 points on the line that you've drawn. And the points do not have to represent actual data pairs. They don't have to be in the data pairs. They have to be on the line that you draw. But they must lie on the line of fit. So we are going to go ahead and look at one that's done. Okay, So let's look at this. Like I said, it is easier to use the ones in the book because they show everything. You can see it very clearly, okay? So we're looking at bird population here. The table shows the number of active red cockadees, whatever you call them, woodpeckers. So woodpecker clusters in part of the National Forest in Mississippi. Write an equation that models the number of active clusters as a function of the number of years since 1990. So here we go. This is the years. 1992, 93, 94, 95, all the way to 2000. So those are going to be your X's, all right? Then the active clusters, those are going to be your Y's. How many active clusters there were each year. 22, then 24, 27, and you can see that they're increasing. So the first thing, before we even plot the points, is your Y increasing? Yep. Are the years increasing? Yep. So it looks like Y and X are increasing together. So you should be expecting a positive correlation when you plot the points. So let's look and see. So we make up a scatter plot. So you're following what they said. Let X represent the number of years since 1990. So 0 is going to be 1990, and 91, 92. But they just did every 2 years, but you understand that that's 1, that's 3, that's 5. This way you can fit it nicely on the graph. You don't have to label every point, every second one, so that people know what you're going by. All the way up to 10, which is going to be the year 2000, okay? Because it's 10 years from 1990. Then again, you look at your data. The lowest is 22 and goes up to 51. So they went 0, then they went to 20, 25, 30, 35, 40. So they did it in 5 increments. Looks like 50, and then this is going to be 55. So it'll fit nicely on the graph. So they label it active clusters, years since 1990. Everything is clear on there, and you can put a title, woodpecker, the increase of woodpeckers, or active clusters of woodpeckers, however you want to title it. So then you plot the data. So we plot all the points. You can see here they've plotted the points. All right. So then this is the extra thing you do. You want to draw a line in the center. Remember, it said that you want to have as many below as above if possible. So right here you've got 1, 2, 3, and here you've got 1, 2, 3. So they've drawn a line right here in the center. So far you're doing good. Now the next thing is number 4. You write an equation using 2 points on the line, on your line. So one line in the year 2, 1992, you had 20. So they picked this point. I'm just going to make it stand out. It's on the line. Then they pick another point on the line. 842 is on the line. It has to be on your line. So those are the 2 points you pick. Now when you make your own, depending on how you draw your line, your slope and your y-intercept might be a little different from someone's. That's why you have to write down the pairs you do. So your slope might be slightly different, might be slightly off depending on what your line is, but it shouldn't be that far. You can't have somebody having a positive slope and someone having a negative. Say your slope is 3, someone else's is 3.5 or 2.7. That's fine. They're all kind of around there. So you're not going to have somebody with a slope of 3 and someone with a slope of 25. That's way off. So even when you do your line, it's going to be close, maybe a point here and there. So they use the 2 points. So you know now, you're going back to all the knowledge of slopes, y-intercept, everything that you've learned. So you have your 2 equations that you pick that are on your line right here and right here. I've made them really stand out. So write them, 220 and 842. The first thing you do is you have to find the slope. So when you do that, 42 minus 20 over 8 minus 2. You know how to get the slope. It is 22 over 6, but you don't leave it like that. You reduce it to 11 over 3. So you know that your slope is 11 over 3. And it's okay to leave it as a fraction. Later on at the end, if you want to change everything to a decimal, you can. 11 over 3 is just over 3 2/3 about. So you have an idea, okay? So you got the slope. Now you need the y-intercept. So you pick an ordered pair. You can pick 220 or 842. They pick the smaller numbers are always easier. 2 and 20 are smaller than 8 and 42, so I would pick 2 and 20. 20, plug it back into the slope-intercept form. You've been used to doing that. So the y is 20 right here, and the x is 2. Okay? So 20 equals 11 times 2, that would now be 22 over 3 plus b, and you can use your calculator. Then you're going to say 20 minus 22 over 3. Plug that into your calculator, and that would be 60 over 3 minus 22 over 3. You're going to get 38 over 3. So now you have the b and you have the slope, okay, right here. Those are the two things you need to write an equation in slope-intercept form. So you go back, an equation of the line is y equals 11 over 3. That's your slope, plus 38 over 3. All right? So what that means is 11 over 3 is the rate of change. That's how many every year. About 3 2/3, just under 4 woodpeckers increase every year. And X is the number of years since 1990, and B is where they first started at 0. So 3 into 33 is 11. So they start about just over 12 woodpeckers in 1990. So when you go back, even though we don't have 1990, that makes sense. It was about 12, and then in 1992 you had 22. So all of that, you should be able to look at the data and make sure that it's fitting the data. So every year you're getting between 3.5, not that you can have half a woodpecker, but approximately close to 4 woodpeckers, give or take. All right, that's on average. So that all makes sense. So hopefully you understand what you did. Plotted again. You plotted the points, then you drew a line in the middle, dead in the center, as best as you could, with the same amount underneath as above. Then you picked 2 points on your line. It didn't have to be the ordered pairs from here. It does not have to be here. It has to be on your line. So we picked this one on the line and this one. 220, 8 years, there were 42 woodpeckers. All right, you got the slope. That should be easy. Once you have 2 ordered pairs, you get the slope. Then you know the slope. The next thing you need is the y-intercept. So you go back to this formula, slope-intercept form. You know that y is 20. You got the slope of 11 over 3 times x of 2, and then you can solve for b. So you just have to be proficient with fractions. You are allowed to use a calculator, understand how to do it. That's going to be 11 times 2 is 22 over 3. That's how I got that. Then you have to subtract that from 20. And if I multiply this by 3, it becomes 60 over 3 minus 22 over 3, which is 38 over 3. So now you have the y-intercept. So here is the equation. You have to understand what that means. The slope means that's how many woodpeckers, active clusters per year. So just under 4. And that means when they first started out, they were somewhere close to 12 woodpeckers. All right, so that's good. The last thing we're going to do real quick is interpret the model, the one that we just did. Okay, so we're going to describe the domain and range. So let's go ahead and make this. Describe the domain and range of the function. All right, so we're looking at the graph here. So when you look at this graph, the domain is the x, so the first one starts at 2 and it goes all the way up to 10. So the domain is between 2 and 10. Then the range is from 20 all the way up to, on your line, is about 48, 49, somewhere around there. So that's where they come up with the domain and range. So from 1992 to 2000, that's from between 2 and 10 years. So that's your domain, and the range is the active clusters between between 20 and 49.3. So you can just round it off. I'm not going to be too tough if you said 49 or 48. It's subjective a little bit, because you can't tell exactly sometimes. So they said that the range is between 20 and 49.3, but you can clearly see on the x's it's between 2 and 10. You don't have to guess on that. So the number of active woodpeckers, so at what rate did the number of active woodpecker cluster change during the period 1992 to 2000? So I had already said this before, didn't realize they were going to ask it. So it says a number of active woodpecker clusters increased at a rate of 11/3, or about 3.7 woodpecker clusters per year. So that's what the rate means. All right, guys, so we're at the end of this chapter. Just work on your homework. Show all your work.